Hi Year 9. Okay, so for today's lesson, we're continuing with our energy lesson for Year 9 Science Topic 2. And in Lesson 2, we're going to be looking at elastic potential energy. So, for today's starter task, while everyone's arriving at the lesson, I'd like you to watch this video showing the effect of elastic potential energy during a bungee jump. While you're watching the video, can you think and be ready to share? We want to think about what we mean by elastic potential energy. Also referring back to our previous work on forces, think about the forces that are acting on the jumper, both at the point of jumping, as they travel down and accelerate, as they reach the maximum stretch of the bungee elastic rope, and as they're going back up. And also thinking at each point in the jump, what energy changes are occurring at each of these points as they jump from the platform, as they're accelerating down, as they're then converting the energy change as it changes from the full extension of the rope back up. I'll not give you too many more hints. So have a think about that and be ready to share that with everyone. So today's learning objectives are first of all to continue our reflection on our prior knowledge of types of energy, and then to be able to know examples of how energy can be stored as elastic potential energy being transferred to other energy sources. We'll do that through our discussion on the video we watched as our starter task and looking at a bungee elastic. We're also going to be carrying out another home practical today, looking at a catapult and the energy changes involved, including elastic potential energy in the use of a catapult. So as we recapped last lesson, we know that there's many different types of energy, active energies, and also energy stores. The energy store that we're going to focus on today is elastic potential energy. In today's task, as part of your home science learning, you're going to make and test your own catapult. Now the equipment list, like always, is a suggestion and you can substitute with similar items that you might have at home. So let's just go through these and have a think about what you could use. We've got craft sticks or ice lolly sticks. Really any thin pieces of wood work for this. You could substitute with plastic sticks or anything similar that you have at home, as long as it's fairly strong and able to be joined together in a similar way to the one that you can see in this diagram. Rubber bands will be essential for this, so if you don't have rubber bands, like I asked you in the previous lesson, it's worth trying to get hold of some of those. You can substitute that for maybe hair elastics, that could work as well, but rubber bands are best for being able to assemble your catapult. Plastic bottle cap can be any type of plastic bottle cap, from a juice bottle, a soda bottle, a milk or water bottle, anything like that, just to provide the area for launching. Now hopefully we should all still have glue in our home science kit, but you can substitute that for tack or tape as best you can if necessary. The paints and paintbrushes are completely optional, it's really just to make your catapult look nicer. And the cork is just an option that we can have instead of using the stacked sticks as a fulcrum. I'll explain that a little later. So when you begin to engineer your catapult, the idea is to stack about 8 craft sticks together. You might find, depending on the thickness, and you can play around with this, you need fewer or more, but stacking them together one on top of another and wrapping elastics round the end here and here, as you can see, to hold them together. This is a really nice practical experiment, which you'll see in the references slide. Comes from steampoweredfamily.com, who've got some amazing home science that you can do. So looking at how we've wrapped these together, this is going to create additional stability and strength, and this is going to act as the fulcrum where it pivots for our catapult to go up and down. Now this next part is the really important stage. You want to take a single stick and you want to place that perpendicular, remember here at right angles, to the stack that we have across the bottom. And we do that by setting the fulcrum, that's like the point where it pivots, about a quarter of the way. So if you see, if this is the whole stick, you see we're about a quarter of the way up it. And we stack it here and create the pivot. And then underneath you can put a popsicle stick underneath here, that's just an extra stick under the bottom, and then tie it all together. There's no one right or wrong way to do this, and you should play around with yours to try and get the best amount of stability, but also have the flexibility so that this part of the stick that I'm referring to here is going to pull down and up. and you have that spring-like part of the catapult here ready to launch things. When you're confident that you've got this working and you've got an effective catapult mechanism with springing up and down, at that stage you can then glue on your bottle cap onto the far end of your top launching stick. When you do that, do leave a little bit of room, that's like space behind the bottle cap in this picture, at the end for your fingers to be able to push it down in order to launch. Now, just mention here at this point, there is an alternative to using the big stack of sticks if you maybe don't have that many. If you're able to find a cork, and the key thing about a cork is that it's springy, it's got some flexibility about it. If you have a cork, you can try that as an alternative, as pictured in this diagram. It just takes away from the perpendicular stack of sticks, and instead of that you can try using a cork. So if you've got corks available, do give that one a try as well and see what you think is going to work best for your catapult. You can see in this diagram better that when you're pulling the catapult down, the space here for the finger left behind the glued on bottle cap. So now it's over to you. You can use all the instructions on the lesson PowerPoint and also on today's worksheet, which you'll submit at the end. On your worksheet, you've got a space here for your design part of making the catapult. So using whatever materials you have available and the instructions that we've gone through in today's lesson, you should try to create your own catapult. When you've done that, it would be great if you could take a photo and upload a photo onto your worksheet so we can share your finished catapult. Then for part 2, we have the main part of our scientific work today. We're going to be testing our catapult. You're going to be using it to launch small objects. Now, obviously, thinking carefully about safety when doing this, make sure there's no small children around, that you're not pointing the catapult towards any people or any breakable objects. So find somewhere safe to do this. Outside in the garden is great if weather's okay, or just do that in a room, but just making sure the direction you're firing it in is safe. Okay, you then want to measure how far these objects travel. So you want to find suitable objects that are able to fit in the bottle cap and be transported over. It might be something small like jelly beans or small toys, but like I say, just be careful because some things can actually travel at quite a good speed if your catapult works really well. The key thing at this point is to think about your scientific method. In Year 9 now, we've spent a lot of time looking over this, thinking about making things a fair test, looking at our independent, dependent and control variables, and recording observations accurately and any data that you record as well. So I haven't given you a table or any other forms of data collection structure here because I want to see how well you remember these from previous lessons in Year 8 and Year 7. If you need extra help with this, please just drop me a message. But what I would like you to do is to decide and list your variables and then record your data carefully. I think in this experiment, for most of you, that will take the form of quantitative data. That means recording how you kept the object the same that you were using to measure, how you recorded the data itself, so how you kept everything else the same to make it a fair test. And then for the quantitative data, you are likely to need an appropriate table to record that data. Perhaps you're going to do other things like several repeats and thinking about how that will improve the reliability of your experiment. Okay, if time allows, do try modifying some different variables, not just massive objects. You might think of other things. So just go through all the possible things that you could change about your experiment and then decide what you want to be your independent variable. As always, I know many of you are always looking for some extra challenge. So here are some suggestions. You may have some others. If you want to run them by me, just speak up or drop me a message. One suggestion is to vary how far you set your sticks up the stack. Okay, so you may want to move the stick which is acting as a fulcrum to a different position. You could change the height of the stack to see how that affects your results, so making that stack much lower and then maybe a medium height and then much higher, and trying those 3 different variables to see how it affects the distance travelled by the object. Remember, if you do that one, you need to keep everything else exactly the same. If you've got different sized craft sticks or different sized lolly sticks, or even if you're able to cut them, you could try making the length of the catapult of the perpendicular stick varied in order to see how that affects how far the objects travel. You could also try gluing an extra craft stick on top to make it even longer. That's an extension of the middle point before you add the bottle cap to make it even longer. That would have to be very well fixed because otherwise it might break when you apply pressure to it. And the other thing you could try is using different materials, like we said, using a cork, or maybe try some alternative materials for the fulcrum. Now that's time for you to go and do your home science. Create your catapult, record your data, try some extra challenges if you've got time, and speak to me for any extra help you want with that. Okay, I'm really looking forward to seeing your designs. Make sure to upload a photograph as well as your quantitative data and observations onto the worksheet before you submit them. Well done on all your great work today creating your home catapults. For a finishing activity today, we are going to do this Kahoot challenge. I've set it as a challenge so you can finish it in your own time for those of you that are still finishing off recording your data. And it's just recapping all that we've looked at so far on energy stores and transfers. If you could complete that by the end of the week, so we can see how you all did in the challenge in the next lesson.